Hi, welcome back to the shop. Today we start a new video series on the making of tool holders for the lathe. I gotta ask a lot what kind of tool holder I have on my lathe, and it's a Tripan 111 Swiss made, and I made all the inserts but one myself, and I want to have some more, so I ordered some material and we're going to machine, I think, about 8 of them from the scratch. So let's go to the lathe and I'll show you the tool. Okay, we're over at the lathe and here you can see the Tripan quick-change tool post holder. It's a dovetail design with a piston style clamping. This wedge shaped piece here moves when I turn this hex screw back here. Then it moves and clamps the workpiece. These are made in Switzerland. You can still buy them and they are horribly expensive. They're even more expensive than the multifix holders that are super common here in Europe. The advantage for me with the Tripan is that I can make my own tool holders. With the multifix, with the teeth and the two locking holes, it's pretty hard to make them yourself. That would be a lot of form grinding or wire EDM work. With these, I can machine the dovetail on the shaper or on the milling machine, and I'm ready to go. And I also have a video on the repeatability of these Tripan holders, and it's excellent. The shape of the Tripan holder is very unique. It's triangular in front here, and that has a reason. Normally, you would align it like this. So you have a straight tool holder that goes on here for outside work. And you have boring bar holders that are at an angle. These here, you can drop these in and they are at the right angle for internal work or facing work if you want so. And the trick is, or not the trick, I only have angled tool holders. I made 8 of these angled tool holders, and I use them for outside and inside work. That means that I have constantly to rotate my tool post around for internal and external work, and it's time to make straight tool holders, and that's what we're going to do in this video. Okay, here you can see a sketch from the profile of the tool holder. That's the same dovetail as on my angled holders, but they are straight. I will machine this profile onto a 200mm long bar and cut off 30mm wide slices and machine them to be my tool holders. By doing this, I only have to machine the dovetail once and all will be the same. And as material, I ordered up a bar of pre-ground precision flat stock. It's carbon steel. It's not heat treated. It's just plain mild carbon steel. 0.45% of carbon, and it's pre-ground to the outer dimensions of the tool holder, plus the pre-ground stock has always allowance on it for finishing and grinding. In width it's plus 0.4 of a millimeter, and in height it's 0.25 millimeters in height. The only drawback with pre-ground stock is that it's very precise in parallelism, but it's pretty bad in squareness. I hope you can see the very light gap at the left side of the square. So this material is always very parallel along the length. It's always very parallel along the length, width-wise and thickness-wise, but it's not perfectly square. We will machine that later to be square. But it's almost the right size that I need, and it's nice material. Okay, I thought of 2 pieces which will each give me 5 of the tool holders. So we're making 10 of these tool holders in total. The first step will be to rough out this area where the dovetail will be, and then we will cut the actual dovetail to match this one, and I will also show you how to compare these two dovetails against each other so we make sure they are all the same. I set one of the 2 blocks up in the shaper, and we're going to rough out the dovetail. First we're going to cut a slot 25 millimeters wide and 6 millimeters deep. And then we will do that to both blocks, and then we will come back and machine the actual dovetails into this block. So first we rough out. I have a tool in the shaper that looks like a parting tool from the lathe. In fact, it is one of my parting tools. I can plunge down with it, and then I can move over to do the actual cutting, and I will show you that. First we move over. I laid out 2 lines here which give the dimensions of my slot that I'm going to cut. First I have to touch up on the surface, and I'm doing this by moving the ram of the shaper back and forth and lowering the tool until it touches the layout die. There we go. That's my 0. 0 of my surface, of course. I can move back to the outside and move over. So I'm very close to my layout line. And now I'm going to plunge down 1 millimeter and let it traverse over. Some cutting oil, and now we feed down. Okay, now we are down 1 millimeter. We get some more cutting oil on there and engage the cross feed. Okay, that was the first pass, first roughing pass. and I can return, go down another millimeter, do cross path and so on and until we hit 6 millimeters of depth. But I will do that off camera or in fast forward because this gets boring for you to watch. Okay, I roughed out the slot in both of the tool holder blanks, and now I'm going to cut a relief in the center because the dovetail has on the original holders a relief, so it doesn't rock on the center. It's only bearing on the outer surfaces of the dovetail. That's common practice when you make a dovetail. And I'm just using a 90-degree pointy 90-degree tool to cut a 5/10 millimeter deep relief. And as you can see by the layout blue here, I scribed 2 lines from where to where the relief is going. Okay, I reached the second layout line, and now I'm going to check the depth of my relief cut in center here. And I'm using my depth gauge. And we have 6.52, and that's perfectly fine. I got both pieces roughed out, and what surprised me, that even with the big amount of material I removed on this side, it stayed very straight. It didn't bow on me. Sometimes even with the pre-ground precision flat stock, the material has a lot of tension in it, and it will bow on you like a banana. And that's not the case, even if the material I bought was not mentioned to be stress relieved in any specific way. So I got lucky on that. I was ready to skim cut both sides to get it straight again if it worked, but I got lucky. And now we can machine out the actual dovetail itself. Here is the dovetail on the original tool holder, and this is a 60-degree dovetail. To do this on a shaper, I ground me a tool that I can come in like this and turn the tool around and do the other side. And this is just ground like a 45-degree lathe tool. To set the compound slide of the shaper, I set my sine bar to a 30-degree included angle, and that's it. That's ready to go. Okay, I clamped my sine bar against the workpiece with this clamp. This is not a canned twist clamp. In Germany we have our own manufacturer of these, and they are called Sponhand. That means as much as clamping hand, because they look like a hand. And now we can tilt. We loosen the screws off the top slide on the shaper. And we can tilt it to approximately 30 degrees. And that is good enough for such a short taper. It's really only a 6mm long taper on these sides of the dovetail, and it's just a clamping dovetail, not a slideways. So this is way good enough. Okay, before we machine the actual dovetail, I need to know how wide this is, and you can't really measure this with the calipers because there is an edge break up here and up here, or a chamfer or a radius. So the theoretical sharp edge is not what you measure here. You measure something. This measurement is absolutely worthless. So the common thing to do is to use 2 dowel pins or 2 gauge pins, drop them into the dovetail on the defining surfaces, and use gauge blocks to measure or check the distance between them. And I have a gauge block stack here that fits perfectly with no play, almost no play, between the 2 dowel pins, and that's what I'm going to use to check the dovetail on my blanks that I'm making. And also I can measure this distance with the calipers for reference, 20.23. And in fact my gauge block stack is also 20.23. Of course this is no reliable measurement. That I got 20.23 is just it just happened. It's not. This is not the way to measure it. It's just for quick reference. The right way is to use gauge blocks. Okay, I got the first one done off camera, and I pulled the tool post off the lathe to have something to test with, and it's a perfect fit with the quickchange tool post with the Tripan. And now I'm going to show you how I did it on the machine. I set the second part up in the shaper, and I have my dovetail cutting tool here, and I will rough it out and then finish the bottom to 6.3mm depth, and then come back and finish the side of the dovetail to a good finish. Then we will change around and do the other side, and then we care about the width of the dovetail. Okay, first I'm touching off on the bottom surface, so I have something to reference off. And I always like to do it by moving it back and forth and advancing the cutter. That's my 0. Turning back. And now we go in and take a first cut. I have layout lines here that show me the rough dimensions of the dovetail. Okay, let's go. Okay, I'm still slightly shy of the layout line. Now I'm going to cut the bottom surface of the dovetail to the final depth. That's it. That should be the final depth. Now, of the first surface, take a measurement, and we are 6.3 millimeters deep. So we finished the first side of the dovetail. We cleaned up the side surface and the bottom surface, and now we need to do the same to the other side. Okay, I pre-finished this side off camera. The bottom surfaces both are done. This side surface is done, and now I need to adjust the width. So I have my 2 4mm dowel pins. Now I can take a measurement to see. Okay, this is 19.35, and I need distance between the 2 pins 20.23. So check it again. Get everything clean. We don't ruin our measurement. Drop in our 2 pins. And take a rough measurement with the calipers. And we're at 20.14, and or let me try this so you can see the measurement. 20.16 and a few. Okay, I took another 2 cleanup and finishing passes on this side of the dovetail, and now when we put in the 2 dowel pins, I can drop in my stack of gauge block. Mr. Fumble Finger. I can get the stack of gauge blocks in very nice, very tightly, and even lay them down flat. And as you can see, this is a perfect fit. Of course, the dovetail on these quick change tool holders doesn't have to be that accurate. They would work plus minus 1 or 2/10 of a millimeter too, but that would change the orientation of the lever that you use to tighten the holders after each change, because you have a different angle on the lever to tighten it, and I don't like it. I want it to be in the same position every time I tighten it. So that's why I went through the trouble with the gauge blocks and the pins to measure it and so on. And also I want to make a good job. Okay, the last step for this part of this video series will be to put some nice chamfers on these blanks. I can do these long sides all now as long as this is one piece, so when I cut it up I don't have to do as much chamfering as it would be if I did them all individually. So let's go. There we go. There we go. Nice chamfers on the long edges of this workpiece. In just a few seconds. Okay, I think that's it for this episode. We have the blanks for the tool holders with the dovetail in them finished, and in the next part we will cut them up on the bandsaw and do some milling machine work. Face off both sides, the sawn edges, and mill out the slot for the tool bit, and drill tap the holes for the clamping screws and the height adjustment screw, and a few things more. But until then, thank you for watching and see you next time.